Good morning. It looks like we're live. Excellent. Go ahead and get everything set up here. Every single time is just slightly off, but in different amounts. All right, so we got that. Let's open up our code editor too. I did not want to open up code on slash. That's not a good idea. Okay, that took a long time for my phone to realize that we had started. Okay, so we have, right, because we switched over to a library system, so we have librs and then in bin main rs. So this is where all of we're just calling our logic, and then lib is where we have our structure. All right, we're on to a worker struct responsible for sending code from the thread pool to a thread. Stacking, good morning. Welcome to the stream. Happy Friday. All right. Well, let's go ahead and get started here. We left a comment in the for loop in listing 20-14 regarding the creation of threads. Here we'll look at how we actually create threads. The standard library provides thread spawn as a way to create threads, and thread spawn expects to get some code the thread should run as soon as the thread is created. However, in our case, we want to create the threads and have them wait for code that we'll send later. The standard library's implementation of threads doesn't include any way to do that. We have to implement it manually. Watched your VOD 20 minutes ago, and you not noticing it was hash panic and creating the docs for new was killing me. Oh, did I? Oh yeah, well, I mean, I wasn't expecting it to actually panic in the docs. It was more of like, oh look, it's the only section that does panic. But yeah, that would be nice if they did that in Markdown, actually, now that I think about it, with the hash panic. That's kind of what it would look like. But I'm glad I was able to add some fun to your Friday. Hopefully we'll add some more today. No, it's a hash space panic. Yeah, it creates the H1 in Markdown. Or it's their thing of Markdown. It actually creates a an actual section of Markdown for panics. That would be more interesting. They probably have documentation about their special version of Markdown. Let's see. We'll implement this behavior by introducing a new data structure between the thread pool and the threads that will manage this new behavior. We'll call this data structure worker, which is a common term in pooling implementations. Think of people working in the kitchen at a restaurant. The workers wait until orders come in from customers, and then they're responsible for taking those orders and filling them. Instead of storing a vector of join handle instances in a thread pool, we'll store instances of the worker struct. Each worker will store a single join handle instance. Then we'll implement a method on worker that will take a closure of code to run and send it to the already running thread for execution. We'll also give each worker an ID so we can distinguish between the different workers in the pool when logging or debugging. Let's make the following changes to what happens when we create a thread pool. We'll implement the code that sends the closure to the thread after we have worker set up in this way. So 1, define a worker struct that holds an ID and a join handle. Okay. I wonder if they're gonna have us do this in the same library, because like we could basically do the same thing. We're implementing threadpull, so we could do pub. Do we want to do it public, or is this really like a private thing, like just struct worker? And we know that we're going to have an ID, which is probably a usize, and we're going to have a join handle. Holds an ID and a join handle. So I guess thread, which is going to be the worker struct is going to go to the top of the page when you're done. Right. Join handle, empty. All right. What are you upset about? Can I find join handle in the scope? Where? Oh, it's thread. Thread. Oh, and I. Interesting. Okay, so thread : : That's better. Okay. Change threadpull to hold a vector of worker instances. Okay, so threadpull now contains, instead of threads, it's going to be workers, and this is going to be a vec of worker. Define a worker new function that takes an ID number and returns a worker instance that holds the ID and a thread spawned with an empty closure. Oh, interesting. Okay, so we'll then implement worker. So function new. This is not going to take self. This is going to be one of those well, it's not delegated functions. It's sort of like, oh, they had a special name for it, and I can't remember what it is off the top of my head right now. All right, so this is going to take an ID of usize, and it's going to return a worker, and looks like just going to return worker. So the ID, well, the ID can just be that. And then the thread is going to be a thread spawn, and the function is going to be just an empty closure. Good morning, Danny. Welcome to the stream. It's been a long time since we've had you here. All right, well, you seem to be upset with just that because how do we have an empty? I guess we have to have something like expected found integral variable. I wonder where the other guy has been. I haven't seen him. You mean Avarice? Yeah, it's been a while, but like maybe some crazy stuff is happening. There's always a lot of, well, so there's always a lot of like weird things that could possibly happen. here. McCroll. Oh, I mean, there's been a few people, but there's like always not too many people. It's mostly you guys who chat. We get a few other people who watch. All right, so we'll have to figure out how to do an empty closure, but we'll see that shortly, hopefully. In the threadpull new, use the for loop counter to generate an ID. Create a new worker with that ID and store the worker in the vector. I watch the VODs usually, but morning chores went fast today. Awesome. Well, I'm glad that that you're able to chat. And Dazed Head, good morning. Welcome to the stream. What's up? All right. Let's all right, so in here, so we have, where are we implementing this? Into threadpull new, use the for loop counter to generate an ID, create a new worker with that ID, and store the worker in a vector. So threadpull new, here's our for loop new. So let threads equals vector with capacity total threads. This is going to be workers now. For and total threads, thread. So it's now actually just going to be, okay, we want to just workers dot push. Oh no, probably want like the index, right? Or I, so that way I can just do workers of I equals worker new and pass in the ID, which would be I. And then you become workers. All right, and that should just work there. All right, if you're up for a challenge, try implementing these changes on your own before looking at the code and listening to 2015. Too late. The only one that I don't know how to do off the top of my head is this empty closure, but we'll be seeing that shortly. Ready? Here's listing 2015 with one way to make the preceding modifications. Okay, so back workers. So we've got this threadpull public function new. Size usize, threadpull, so everything is the same here. Let mute workers. Did I? Oh, it's because I'm not pushing it. I'm just like setting the ID, that's why I don't need to have it be mutable. That's interesting. I didn't think that would be the case. Threadpull workers. Okay, then we have a struct worker, thread join handle. Oh, it's this. It's just an empty block. They were good boys. They named the index or ID. Oh, yeah. I guess I could do that. I could be nice to myself in the future. Okay, so here is just empty block. That's all it is. And you are upset now because you need to be an ID too. Cannot. Oh, so now I'm getting that problem. Fine. It does need to be mutable. Unused variable closure. Okay, so that's gonna come later, I'm sure. We've changed the name of the field on threadpull from threads to workers because it's now holding worker instances instead of join handle instances. We use the counter in the for loop as an argument to worker new, and we store each new worker in a vector named workers. External code, like our server in source bin main rs, doesn't need to know the implementation details regarding using a worker struct within threadpull. So we make the worker struct and its new function private. The worker new function uses the ID we give it and stores a join handle instance that is created by spawning a new thread using an empty closure. This code will compile and will store the number of worker instances we specified as an argument to threadpull new, but we're still not processing a closure that we get in execute. Let's look at how to do that next. So I believe that what this is right here, where we have our execute, we have the closure coming in, but if we take a look at closure and do dot, there's nothing. Yeah, so VS Code is not being helpful in any way to us. Sending requests to threads via channels. Now we'll tackle the problem that the closure given to thread spawn do absolutely nothing. Currently, we get the closure we want to execute in the execute method, but we need to give thread spawn a closure to run when we create each worker during the creation of the thread pool. We want the worker structs that we just created to fetch code to run from a queue held in a thread pool and send that code to its thread to run. In chapter 16, you learned about channels, a simple way to communicate between two threads that would be perfect for this use case. We'll use a channel to function as the queue of jobs, and execute will send a job from the thread pool to the worker instances, which will send the job to its thread. Here's the plan. The thread pool will create a channel and hold on to the sending side of the channel. Each worker will hold on to the receiving side of the channel. We'll create a new job struct that will hold the closures we want to send down the channel. The execute method will send the job it wants to execute down the sending side of the channel. In its thread, the worker will loop over its receiving side of the channel and execute the closures of any jobs it receives. Sea Lion just got another major update yesterday. Do you have a JetBrains license? No, I don't. I'm finding VS Code with RLS getting worse and worse. Isn't Clippy coming out soon in stable though? Well, when that happens, I bet VS Code will get significantly better again. I haven't played with JetBrains in a long time, so I wouldn't mind. We can certainly try. Don't they have a community edition that is free? Let's start by creating a channel in threadpull new and holding the sending side in threadpull instance as shown in listing 2016. The job struct doesn't hold anything from now, but will be the type of item we're sending down the channel. Okay, so we're creating a channel in threadpull new. So if we take a look, well, what's interesting is that we've added on, so in struct threadpull, we now have senders. We have to also use standard sync MPSE, sender MPSE sender job. And then in threadpull new, we let sender receiver equals MPSE channel. I'm starting to remember that now a little bit. We have our workers. Threadpull is now workers and then the sender. So that's all we care about. We don't care about the receiver at this time. All right, so I don't know for VS Code, but on Atom, I use the nightly RS for my stable projects. Wait, you can switch RLS itself to nightly, or do you have to switch Rust to nightly, Danny? It's a shame they had a major sale the other day with 50% off. I would have tossed. Oh, don't worry about that. I think there is a free license that is as enough that we need to do that. Plus also I might be able to convince work or something to get me a license. Yeah, Atom can run RLS and nightly while my projects are still unstable. Oh, interesting. Maybe I could try Atom out later. Maybe at the end of this project we can try another. We could try each project try in a different editor. All right, so we need to bring in standard sync MPSE. So we'll do that first. Use standard sync MPSE. Then we're going to have the sender in the thread pool. That's MPSC sender and then a job. So this is going to be sender. Is it sender or senders? It's just sender. So it's the MPSC sender job. It gives us that. Cannot find type job in this scope. So, oh, we're also gonna have to create a struct job. So I see that. I'll just go down here and add this at the bottom. Struct job. Okay, so that fixed that. VS Code does use RLS nightly. Should have Clippy then. Is there a way for me to tell? It's not really telling me anything by mousing over it. Oh, I need to install Clippy. Okay, we could try that. Let's open a new tab. Is it just it's not a local, right? It's a global, so like cargo what is it? Cargo install Clippy? Is that the way to do it? It's a to do. It's not worth it right now. Oh, that's too bad. All right. It's a 10-line command that I can't remember off the top. Oh wow, that's a lot. All right. Okay, so we have struct job. Now in the implement thread pool, we need to now like destructure sender and receiver out of the tuple that MPSC channel runs. So let's grab those. So in threadpool new, we have let workers. We can also say let sender receiver equals, and is that order, right? Yeah. MPSC channel, just like that. That's not what I want to do. Okay. Then we're just going to add in the sender, because that's all we really care about, into the thread pool. So sender. Perfect. So that adds that in. Receiver, I think I could probably just underscore that to make it not care that we're not using it. Also, this struct is not being used. And that's it for that one. Rust up component add clippy dash preview dash dash tool chain lightly. Yeah, that's a no person. But let's try it, Danny. I trust you, so I'm willing to try this code. Well, okay, that was really fast. Is there anything that I need to do here that's different? Or is it just like gonna change RLS to be better? Okay, I'm not gonna worry too much about that right now. In threadpool new, we create our new channel and have the pool hold the sending end. This will successfully compile still with warnings. Let's try passing the receiving end of the channel into each worker as the thread pool creates the channel. We know we want to use the receiving end in the thread that the spawners spawn. So we'll reference the receiver parameter in a closure in code. The code in listing 2017 won't quite compile yet. So in threadpool new, what is it saying that we're doing? Okay, so workers push worker new ID and receiver. Okay, so that's what it is. So we do need the receiver here. Worker new ID and the receiver is just another argument in. Okay. This function takes one parameter, but two parameters were supplied. My for loop is wrong. For ID in 0 to total threads. Only takes one parameter. Oh, am I supposed to pass in is it wanting me to pass in a tuple? It's not pushing anything into the vector. Aren't I like setting it according to the ID? Like workers of like position 0. Workers of position 1, workers of position 2. That's sort of like feel that it's doing. And I think this one is new workers push, worker new, ID and receiver. Oh, worker new. So I have to come down to worker new, and the second thing is the receiver. So in here, worker new, we have to update this. So this is going to be a receiver, which is type, what was that? MPSC sender. So MPSC receiver. Wrong number of type arguments, expected 1, found 0. I wonder if it's going to be the same thing of just job. It might be. Okay. Threadpull that. Then in worker we have MPSC receiver job. It is. Okay, perfect. Let thread spawn, and then we just pass in receiver into here. So thread spawn receiver. And we're not really doing anything with it. And this is definitely it's not pushing anything into a vector. Well, so it's not pushing, but it's like assigning into each. I mean, isn't this assigning into each specific ID or each specific index of the vector? So like for ID in 0, so that means it's going to be 0. So the first one will become the result of calling this. Oops, I did not want to open Slack. I wanted to close this. Now I'm going to have to wait for Slack to open so I can close it. Sure, it's making an ID, but it's not doing anything with it. Well, so workers of position ID is set to be equal to worker new, which passes in an ID and a receiver, which that one is still use a move value receiver. Oh, I'm getting multiple of these. So I'm gonna have to found reference. I wonder if I can reference it here. Not be sure. Oh, we're gonna run into the problem where we're gonna have to use like a smart pointer, aren't we? That's what's gonna happen. I bet they're running us into this problem on purpose. Because like we're not allowed to do this. We try to run this error, we get the problem, use the move value, which we ran into. If we had read, we would have seen that. The code is trying to pass receiver to multiple worker instances. This won't work, as you'll recall from chapter 16. The channel implementation that Rust provides is multiple producer, single consumer. This means we can't just clone the consuming end of the channel to fix this code. Even if we could, that's not the technique we'd want to use. Instead, we want to distribute the jobs across threads by sharing the single receiver among all workers. Additionally, taking a job off the channel queue involves mutating the receiver. The threads need a safe way to share and modify receiver. Otherwise, we get race conditions, as covered in chapter 16. Recall the thread-safe smart pointers discussed in chapter 16, to share ownership across multiple threads, and allow the threads to mutate the value. We need to use arc mutex t. The arc type will let multiple workers own the receiver, and mutex will ensure that only one worker gets a job from the receiver at a time. Listing 2018 shows the changes we need to make. So we need to bring in arc and mutex. So we need to bring in arc and mutex. Then in here, threadpull. So when we say like let receiver, so right here, we're going to shadow receiver, let receiver equals arc, create a new arc, new instance of arc, and set it to a mutex, new, so new instance of mutex, then the receiver goes into there. So that's going to put the receiver onto the heap and then just store a location in memory, so a reference to where that memory is in the heap, the receiver is in heap, to the arc. Then we're just going to pass in we're going to clone the arc because that's possible to each worker. And then in worker, we now need to it's going to be ugly, horrible, but it's arc, mutex. Then we'd say what exactly it is that goes in here. So that's fun. Let's bring in arc and mutex. So standard sync. Use standard sync arc. Actually, can't I do this? Arc, mutex. To bring in both of them at the same time instead of two-lining it. Okay, so then the next thing we need is shadow receiver and set it to a new arc and a new mutex. So let receiver equals, so it's arc new, and this one is going to be a mutex new, and this was finally going to be the receiver. How did I get myself down there? All right, so we have that. Then in here, workers ID, we pass in a receiver, but now it's saying, hey, we're passing in the wrong thing. Also, we want to pass in worker ID receiver. This is really going to be receiver dot clone, right? Oh, it's arc clone receiver. Okay, so it's arc arc.clone, and we pass it in a reference to receiver, so that way it can clone the arc. Expected values found struct arc. Oh, interesting. So it is the double. Let me try this again. I was a little bit confused because it didn't give me the auto complete here. Yeah, there's no clone here. Yeah, that's the thing. Like, so if JetBrains has better support for like telling me what's in the actual structures and objects, that would be so much better. Okay, so clone, and we want a reference to receiver, which is of course this other arc here. Now this is saying, hey, we're passing the wrong type. So it found type, and then it just gives us this entire thing. I should be able to copy that. I should be able to copy this. Ah, okay, fine, never mind. I should be able to run this here. Argo run. Argo run. Get the error. Then copy this directly. Come down to here and say, okay, well, receiver here is really going to be this. So standard sync arc, standard sync mutex, standard sync MPSE. So what's interesting here is that because we have standard sync arc, these can go away. and just use those specifically. It makes it a little bit easier to read. So receiver arc, mutex, MPSE, receiver, and this is the type placeholder is not allowed within types and signatures. I believe it's a job. All right. No other red errors. Perfect. Yep, and I think that's exactly what we've got. In threadpull new, we put the receiving end of the channel in an arc and a mutex. For each new worker, we clone the arc to bump the reference count so the workers can share ownership of the receiving end. With these changes, the code compiles. We're getting there. Implementing the execute method. Let's finally implement the execute method on threadpull. We'll also change job from a struct to a type alias for a trait object that holds the type of closure that execute receives. As discussed in the create type synonyms with type aliases section of chapter 19, type aliases allow us to make long types shorter. Look at listing 2019. Okay, so we have type job, box dynamic FN once plus n plus static. Oh, this is what we were going to want to set. So we need to create a new type job, which is going to be a box type dynamic dyne FN once, but it also has send and also has the static lifetime. Then we implement threadpull. Public function execute where f is fn once, let job equals box new f. I'm surprised we didn't like implement job for threadpull to like really make sure it's sending it up. Sender send job unwrap. Okay, so let's set this up. So type job equals, so we're going to use a box, which do we have? We also have a box set up, but it'll tell us where to bring it from. Box dyne fn once. So here's our struct job. So let's also create our trait right above it. So type job. Oh, it's type job, not trait. So type job equals, it's going to be a box, and this is a dyne fn once, and then it has send and static. So plus send plus lifetime of static. So that should work there. Send, oh right, it's send with a capital S. I keep on forgetting that. I know, I made the exact same mistake yesterday. That's gonna take me a while to get used to. So I don't think I need struct job. I think I just do that. All right. Then we implement threadpull, public function execute. So if we take a look at threadpull, right, because here's where the type is this. Threadpull, public function execute. None of this is changing. We still have f function. Okay, so this is all the same. Where fn once plus send plus static. This is all the same. Then we have our our body where we're just going to let job equals box new f. So here's where we're going to start doing things. So let job, and it's going to be a lowercase job because we're not doing anything with the type. This is actually just a variable, equals what is it? It's the closure. Oh no, box new and then So we're going to hold the closure in a box. So we need to do box new closure. Once we have that, then self sender send that job, which is the box, and then we unwrap the box that we actually send the thing. That job might need to be before the implement. It might complain about it. Let's find out. I'm actually really curious about that, whether or not it's going to be available to it. Self-sender send job unwrap. So, okay. So then we're going to say, okay, we have our sender. We want to now send our job, but we want to unwrap and then unwrap the entire thing. Teal, is it Tealkine? Tealkine. Good morning, welcome to the stream. It's compiled, so it shouldn't. Right now, it's not complaining about it in RLS, so my guess is that it's fine with it. And it's probably because it's doing that one pass to search for everything, and if it can't find it at the end of the pass, then it will complain. Like, I'm not sure the compiled nature of it matters, but they are static types. Okay, so this brings us down there. After creating a new job instance using the closure, we get an execute. We send that job down the sending end of the channel. We're calling unwrap on send for the case that sending fails. This might happen if, for example, we stop all of our threads from executing, meaning the receiving end has stopped receiving new messages. At the moment, we can't stop our threads from executing. Our threads continue executing as long as the pool exists. The reason we use unwrap is that we know the failure case won't happen, but the compiler doesn't know that. But we're not quite done yet. In the worker, our closure being passed to thread spawn still only references the receiving end of the channel. Instead, we need the closure to loop forever, asking the receiving end of the channel for a job and running the job once it gets one. Let's make the change shown in listing 2020 to worker new. Okay, so worker new. So under function new, we have IDU size, we have a receiver, we return a worker, that thread equals thread spawn. So we need to move into it. Then inside, we're gonna have an infinite loop that let job equals a receiver. So it's gonna receive the job if there is one. Worker got a job executing and printing the ID, and then we dereference the job and execute it. And of course, we're returning the worker ID in the thread. All right, so this will be fun. Okay, so we need to make sure we move into it. So in worker new, thread spawn, we're going to move. Like whenever it finds a variable in here, it gets moved into it. Then we have an infinite loop. We don't need this receiver. It's not really doing anything for us right now, as it is. So we need an infinite loop. Inside of the infinite loop, we're going to create a new variable job and set it to the result of running receiver. So receiver.lock, its result, we unwrap it. Then we run recv on that result. Then we run unwrap on it again to get the job out. All right, so receiver dot what is it? It's dot lock. So we need to lock it. Then I think we need to unwrap it. Yep. That's not what I wanted. Unwrap it. Then we need to recv it. We have a rec v. No, it doesn't. Okay. So then we rec v it. Then we unwrap it again. Interesting. Oh, and you know what? I forgot to set this to a so let job equals. So we're grabbing all this out because job isn't scoped. It exists in all contexts, no matter where it's defined. Oh, the type. Yes. Well, it's defined. It's also private now, right? So it's only defined within this file, within librs. Unless I'm mistaken. Okay, so then printline worker, we got a job, you know, so worker ID got a job executing, and then we execute this job. Okay, so we can do that. I mean, within the file, yes. Okay, so where were we? Here's this. Then we can have our print line. All right, so worker ID got a job executing. We got the job. Is it? No, it's just ID. Right, because so it's available of this. So we're moving ID in. That's what we're doing. We're moving ID in, and we're moving receiver in. And then so. All right, we do this with parentheses to sort of like contain this in here, but it makes it a little bit easier for us to write it. We're going to dereference the job. So that gives us the actual, this gives us the actual function, the closure we want to call. Then we call the result of that. And I don't think we need to return anything. Cannot move value of standard type ops fn once plus standard marker send. The size of standard ops fn once plus standard marker send cannot be statically determined. I thought we set it to be. Did I? Well, it doesn't look like it did that wrong. Maybe there's something else going on. Or maybe it'll be in the future. Oh, nope. It's an error we're supposed to get. That's what it is. Here we first call lock on receiver to acquire the mutex, and then we call unwrap to panic on any errors. Acquiring the lock might fail if the mutex is in a poisoned state, which can happen if some other thread panicked while holding the lock rather than releasing the lock. In this situation, calling unwrap to have this thread panic is the correct action to take. Feel free to change this unwrap to an expect with an error message that is meaningful to you. If we get the lock on the mutex, we call recv to receive a job from the channel. A final unwrap moves past any errors here as well, which might occur if the thread holding the sending side of the channel has shut down. Similar to how the send method returns error if the receiving side shuts down. The call to recv blocks, so if there is no job yet, the current thread will wait until a job becomes available. The mutex t ensures that only one worker thread at a time is trying to request a job. Theoretically, this should compile. Unfortunately, the Rust compiler isn't perfect yet, and we get this error. So this is the error we just got. This error is fairly cryptic because the problem is fairly cryptic. To call an fn once closure that is stored in a box T, which is what our job type alias is, the closure needs to move itself out of the box T because the closure takes ownership of self when we call it. In general, Rust doesn't allow us to move a value out of a box because Rust doesn't know how big the value inside the box will be. Recall in chapter 15 that we used box T precisely because we had something of an unknown size that we wanted to store in a box T to get a value of a known size. As you saw in listing 1715, we can write methods that use the syntax self box dine self which allows the method to take ownership of a self value stored in a box T. That's exactly what we want to do here, but unfortunately, Rust won't let us. The part of Rust that implements behavior when a closure is called isn't implemented using self box dyn self. So Rust doesn't yet understand that it could use self box dyn self. In this situation, they take ownership of the closure and move the closure out of the box. Rust is still a work in progress, with places where the compiler could be improved, but in the future, the code in Listing 2020 should work just fine. People like you are working to fix this and other issues. After you finish this book, we would love for you to join in. So, a little bit of call to action there. But for now, let's work around this problem using a handy trick. We can tell Rust explicitly that in this case, we can take ownership of the value inside the box T using self box dyn self. Then once we have ownership of the closure, we can call it. This involves defining a new trait, fnbox, within the method callbox that will use self box dyn self. In its signature, defining fnbox for any type that implements fn once, changing our type alias to use the new trait, and changing worker to use the callbox method. These changes are shown in Listing 2021. There are poison errors in Volcano you should fix. Oh, maybe. Is Volcano your game engine, Danny? Are you still making a game engine, or are you just making a game? All right, so we need to create a trait fnbox. Function callbox. Volcano is the Rust-esque Vulkan crate. Oh, so it's not something. I'm making a game engine and a game, but it's in TypeScript. Okay, so you're making more of a JavaScript game. So Volcano is the Rust-esque. Okay, interesting. Trait function fnbox. Function callbox self box dyn self. All right, let's do this. Still got a bunch to go through here. So actually, I think I'm gonna have to end up calling it before we end up going through and doing too much of this. Let's implement this, and then we'll pause on like this line. And the reason for that is I've got to get ready for work. It is close to 8 o'clock, and it's gonna be. Today is Friday. They won't mind you coming in around noon. They might today, but that's because it's a special day for me at work. And I'll get to that in a little bit. Okay, so let's do this really quickly. So trait fnbox. Put this down here. I like the idea of creating. Of doing the traits at the top because they're easier to see. I should probably do types at the top too, but that feels similar to the structs. It's 11 p.m. on Friday over there. Well, I guess I'm going in near noon where you are, Tilkine. Trait fnbox. Oh, so I'm creating an fnbox. Then it's gonna be function. Oh, sorry, I didn't see the PM. I thought it was AM. That is. Is that Europe? I don't know my time zones very well. It's 11 a.m. somewhere in the middle of the ocean. Well, I mean, I guess I can go onto a cruise ship, work there. FN callbox Australia. Awesome. So call box, and then self. Okay, this is going to take in self, which is a box of dynamic self. So box that parentheses? No. So type dyn self. You are upset. Expected trait found self type self. Self is only available in traits and impulse. It's a trait. It's allowed. It's a treat. What did I do wrong? Or does it need to wait until I actually use it? Okay, so then we implement fn box for f. Okay, so we need to create a generic implementation for this. So for this trait, we're going to implement fn box for the generic f. Okay, so implement f. We tie this to fn once. Just an empty, so it's not going to take anything in. For fn box implement fn box for f. Sorry, it's not that. It's going to be. Did I just delete all my stuff? Implement fn box for f. Then create a message enum. Oops, spoilers. Oh, is that coming up? It's not a game. It's spoilers are acceptable in programming. I think that's just pair programming, maybe. Okay, so then we have a function callbox. So we're now going to implement this callback function. So function callbox. It's going to take in the self here, right? So there's going to be self. It's going to be this exact same thing. So dyn, in this case, f. And then it's just, this is what it's going to execute. So now we're going to dereference the self and execute it. And we're returning the result of this, I guess. Okay, so expected trait found type parameter f. Well, that's what we're supposed to, that's what it's asking us to do. Okay. Type job equals, down here we have our type job equals, this is all the same. Okay. Implement worker. So let's go, here it is, implement our worker. We have our new ID usize and our receiver. That's all the same here. We return the worker, let thread equals thread spawn move, which is, we have here. We have our infinite loop inside of the closure. That job equals receiver, lock, unwrap, rec v, unwrap. So it's all the same thing. Print line this, and then our job. Everything else is the same. Wait. No, I was getting confused at which one I was looking at. Okay, so we have our job, let job equals. This is all the same here. We have our print line, and then we have job call box. So now we just say, okay, job dot call box. We'll just call that and let it do its thing. Since we're not returning anything, we don't really care anymore. Dyn fn box in job. Is that? Interesting that it's using dyn fn box in job, or is it down here? Dyn fn box and job, it's not the same. Type job equals box. Oh, is that where I screwed up? So type job equals box dyn fn box. Oh, I think I mixed that. They changed that. So type job dyn. You're right. Fn box. It wasn't the same. Parenthetical notation is only stable when used with fn traits. Right, it's no parentheses here. Okay. Now we have dyn self, expected trait found self type self, and expected trait found type parameter f. Did you mean fn? No. So I have no idea if this is, if like the next things are going to be more errors, probably, but maybe we'll fix it. Maybe it'll get worse, but that will be a problem for next time. Next time will probably be next week. Try compiling. Sure, let's do it. Cargo run. Expected trait found self type self. Self. Is this the Rust 2018 version of the book? You might want impl instead of dyn. Oh. It is the 2018 version of the book. Impl instead of dyn. Because I am seeing, yeah. Okay, so impl instead of dyn right here. That doesn't seem to like it. Well, we can fix this later. Impl f. So impl f colon fn once. So type fn once for generic type f. Fn box for generic f. Function, so new function call box self box just f. So basically not having to do that thing. So box f and then self. Okay. So basically I just need to do this is what we're getting at. And then it's happy. Okay. So I vaguely remember, like, I was looking at the book and it was suggesting, oh, you could just do whatever, like just use this. It's the new version of the book. But the compiler, when I did rust up, didn't update to that version. That's fun. And now it's running, so perfect. Although we have all these warnings, but that's not that big of a deal. Let's go ahead and update where we're at. So we have in the middle of implementing threads, and we'll close you. And open you back up again. So that way, we're gonna be right here. So I'm just gonna copy and paste this. So currently at, I know this is that. I should also say something like just text. Thanks for the neat stream. Cool to see someone learning Rust. Well, I'm glad you're enjoying it. I'm looking forward to like being finished the book and then like just starting on own solo projects instead of using theirs, which will also be awesome. But thank you for stopping by and for the help. It's been awesome. All right, and we'll open up. Guess it doesn't really matter. Be you. And that means we can now open up where we are. Control C plus V is so much easier though. I know it's easier, but I found that it just doesn't, like, I will never learn it if I do that. I have to write it. Even then, like, it will take a while, like many times of me writing it before I like really get it. He's been learning since March. Don't expect this to much along much faster. Yeah, I'm slow with that too. Although I've been like reading through the book slowly. I bet it would be much faster if I wasn't like reading out loud and going off so many side tangents with each examples. All right, so updated where we are at. This chapter is ginormous. I know I was hoping to get done before the end of the week, but we're gonna get in to next week to finish it out. All right, so normally our schedule has been in these past like months. It's been every single, except for some days, weekday mornings. However, the book is, oh, okay, next code snippet. Oh, okay, repeat. Yeah, I've been actually like reading every word like very carefully, going through that. Nothing was worse than that beating the dead. Oh, we rushed through 18 and 19 so fast. But Tekin Road is what's in the second. Well, that's what we started with. I should probably go back to that. All right, so normally I've been doing this every single weekday morning, with some minor exceptions that I tweet out when it's going to be an exception, at 7 a.m. Mountain Time. But things are going to change just a little bit. And the reason is because today is my last day at Galvanize. So I put in my notice 2 weeks ago, and I'm actually going to be getting back into the development world. I'm no longer going to be primarily a teacher teaching full stack web development. So I am going to be back into the dev world, which also means that I have 2 weeks of fun employment time. So that means on Monday, I expect that we can just stream as long as it takes until we're done. So I believe that we should just stay with the 7 a.m. Mountain Time slot, and then we'll just stream until this project is done. Your stream starts at 11 p.m. over here, so that'll be interesting. Oh, okay. The other thing is my times will eventually change. Like I can't always just do 7 a.m. because I believe I'm going to have work starting with my new company. On the 27th will be earlier. Don't worry about me though, bloody Australians. I'm sorry about that. I do have all these videos archived over onto YouTube. I like you better as a teacher. Well, I am still going to be streaming. That's the big thing. I still am gonna find time to stream. The question is whether or not long term I'm gonna be streaming in the morning or in the afternoon my time, or on weekends, or just create videos or do something else. I'm still gonna figure out some way to continue to make content. But for the next 2 weeks, you get me at the same time, but also for potentially longer or maybe random times during the day. There are always chances to teach day to day too. You probably do in your daily life and you don't realize it. Oh yeah, all the time. Also, like I have some ideas of how to create like a mentoring system because I want to start doing that. And with time in the next 2 weeks, I have a lot of little micro project ideas to work on. And I plan on doing them all on stream because that's what I found the best way to keep myself on track. But with that being said, there's a giant party tonight at work. After work, we're gonna do a game night. So I've got to pack all my like gaming computers up so that I can go and be part of that. And it's gonna be good. Anyways, thank you everybody for stopping by. I don't expect to do any streams this weekend, but next week, Monday, 7 a.m. Mountain Time. I plan on finishing this project, however long it takes. Tealkind, thank you for stopping by. I know it's super late for you. And Danny, awesome to have you chatting. I know that you're often watching. And Stacking, thank you so much for the what you've been helping out with. I know that we have the, I guess it's not Vin, it's the live. We have the question of whether or not this is gonna work. So we're gonna find out on Monday whether or not this works or not. 3 a.m. is super late. This is so bloody students. Yeah, well, we need sea lion so we can use a debugger. Well, we'll you know what? The next project I may figure that out. So anyways, with that, I hope that you all have a great rest of your days. Have a great night, Tealkine. Have a great weekend. And I'm going to see you all next week. Rest needs a proper debugger. Well, it's a young language. I'm sure it'll be coming out shortly. And with that, see you next time.